everybody, it's Mrs. Mann, and I'm here to explain the math behind the magic of the crystal ball. So, there were a couple different pieces of quote unquote magic that were going on. The first of which actually has nothing to do with math, and that is that every time you clicked try again, it actually shuffled the icons. So in the first go round, I just kind of took some snapshots. If I were thinking of 36, I'm thinking of a star and crescent. But the next go round, if I'm thinking of 36, I'm actually thinking of like a medal hanging around your neck. Okay, so that was the first way that they sort of tricked us. The second is the math. So let's look at some examples. I just pulled out a two-digit number from every group of 10, starting off with like 14, and then I went to 22, and I went all the way up to the 90s, 96. And I worked through the math, and I subtracted the sum of their digits. I want you to look at the numbers that I wound up with. Now, I'm always saying that math is just the study of patterns. So I want you to try to figure out a pattern. And hopefully that you notice that no matter what you wound up with, they are all multiples of 9. If you do the math correctly, you will always wind up with a multiple of 9. So, if we think about it from that perspective and we look back at the icons, I have circled all the multiples of 9 that you could wind up with. In this case, every single one of them is a star and crescent. And in this case, every single one of them is a medal. They do throw you off a little bit because you'll see a star and crescent for other numbers as well. Here's one at 4. Here's a medal, hanging around your neck at 79. So they kind of trick you that way. But no matter what, you're going to be thinking of that icon. So I wanted to dive into the math behind this. And we're going to do it algebraically and with a number example. So let's say that I call my two-digit number X and Y, kind of like this, but I can't really write it X, Y, because whenever we have two variables with no sign in between them, it actually means to multiply. So if we started off with, like, let's say 58, we don't want to write it XY because that would mean we would be multiplying these together and getting 40. So let's think about what 58 really means. Okay, 58 really means 50 plus 8. Because whatever digit is in the 10 spot is really representing 10 times that value. So if we think about it with our variables, we would really write this as 10x plus y. All right, now the next step was to add up the digits. So we would add up 5 plus 8 and get 13 and subtract. Okay, well, with our variables, we would add up x plus y and then subtract. So when we do this with our numbers, 58 minus 13 is 45, again, a multiple of 9. Now this is where it gets interesting with the algebraic translation. I have a 10x and I'm subtracting an x, so I'm left with 9x's. If it helps you to put a 1 as the coefficient here, be my guest. And then I have a plus y, and remember I'm subtracting this y. Well, what happens when you have y and you subtract a y? They actually cancel out. So what are we left with? We're left with 9x, which means that no matter what number you start with, not only will you always wind up with 9 times whatever your x value was, but it also means that any multiple of 9 will be your answer. So if we go back to our examples here, you'll notice that 9 times 9 is 81. 6 times 9 is 54. 2 times 9 is 18, and so on. So that is the math behind the magic of the crystal ball.